Einstein showed that his theory of special relativity that it is necessary to treat mass as another form of energy. Before the advent of this theory of special relativity, it was presumed that mass and energy were conserved separately in a reaction. However, Einstein showed that mass is another form of energy and one can convert mass energy into other forms of energy, say kinetic energy, and vice versa. Einstein gave the famous mass energy equivalence relation E is equal to mc square. Here, the energy equivalent of mass m is related by the above equation, and c is the velocity of light in vacuum and is approximately equal to 3 into 10 raised to 8 meter per second. Experimental verification of the Einstein's mass energy relation has been achieved in the study of nuclear reactions amongst nucleons, nuclei, electrons, and other more recently discovered particles. In a reaction, the conservation law of energy states that the initial energy and the final energy are equal, provided the energy associated with mass is also included. This concept is important in understanding nuclear masses and the reaction of nuclei with one another. We may expect that the mass of nucleus is equal to the total mass of its individual protons in nucleus, because nucleus is made up of neutrons and protons. However, the nuclear mass m is found to be always less than this. For example, let us consider OH16, a nucleus which has 8 neutrons and 8 protons. We have mass of 8 neutrons is equal to 8 into 1.00866 U. Mass of 8 protons is equal to 8 into 1.00727 U, and mass of 8 electrons is equal to 8 into 0.00055 U. Therefore, the expected mass of OH16 nucleus is equal to 8 into 2.01593 U. It is equal to 16.12744 U. The atomic mass of OH16 found from mass spectroscopy experiment is seen to be 15.99493 U. Subtracting the mass of 8 electrons from this, we get the experimental mass of OH16 nucleus to be 15.99053 U. Thus, we find that mass of the OH16 nucleus is less than the total mass of its constituent by 0.13691 U. The mass difference of nucleus and its constituents, delta M, is called mass defect and is given by delta M is equal to ZMP plus A minus ZMN minus A. What is the meaning of mass defect? Einstein's equivalence of mass and energy plays a role in this one. Since the mass of oxygen nucleus is less than that of the sum of masses of its constituents, the equivalent energy of oxygen nucleus is less than that of the sum of the equivalent energies of its constituents. If one wants to break the oxygen nucleus into 8 protons and 8 neutrons, this extra energy delta mc square has to be supplied. This energy required, EB, is related to the mass defect by EB is equal to delta m c square, which is known as the binding energy of the nucleus.